This is our AVP evaluation, and the members of the team are Paulina Barrios Cruz, Héctor Conejo Morales, Vanessa Flores Morales, and Linda Michelle Silva Ramos. So we have two different objectives on this AVP evaluation. First, the student understands and applies the concepts of chemic to solve problems in the health area in their daily life, and also to relate the research points to the investigation in a clear way, identify all the topics and describe what are they about and how do they relate to the investigation. These are problems we need to solve. And these are all of our Turing questions that we need to solve in this AVP evaluation. So first of all, we needed to identify what we already know and what we didn't know that we have to know to solve all of these questions and points. So first, we need to identify that, and then we know that ammonia, NH3, is colorless and is a gas composed of nitrogen and hydrogen. The major use of ammonia is in a fertilizer. This is the direct constant of the chemical reaction of the element. So we have different elements in this constant, and we also have hydrogen and nitrogen. This reaction requires the use of a catalyst in high pressure and elevated temperature. So the equilibrium between the elements and the ammonia favors the formation of the ammonia at a low temperature. But high temperatures are required to achieve the satisfactory rate of ammonia formation. So we have different characteristics of the gas state of matter because we're talking about a gas. Gases have no definite shape, they have no definite volume, their particles move in random motion, and they have little or sometimes no attraction to each other, and they are highly compressible. They have different properties like expansibility, diffusibility, low density, compressibility, and exertion of pressure. So now the chemical equilibrium and equilibrium constant. The chemical equilibrium is a state in which the reactants and the products of a chemical reaction, the left side and the right side, have the same number and amount of the elements. So the equilibrium constant comes in hand with this last concept. The equilibrium constant is a ratio between the amount of reactants and the products that determine the chemical behavior. I'm going to be explaining the valence reaction, and we're talking here about an heterogeneous or an homogeneous reaction. We're talking about both of them because on the reaction part of the equation, we have the elements in different states of matter. We have water in a liquid state and NH3 on a gas state. But moving on into the products, we can see only one state of matter, which is gas. And here we're talking about of an homogeneous reaction. So below we have the equations of both reactions, the heterogeneous and the homogeneous one. Now I'm going to talk about the low yield. There are a lot of factors that might be causing the low yield, and most of them are really common. So we have the change in temperature, in which the temperature isn't the right one for the reaction to be completed. We have that the concentration can be lower than needed, and this will be affecting the product and also the reactants. And we have also that the reactants have a very high concentration. They have to have the exact amount of concentration for this reaction to work. And the states of the elements are not right. If we do not have the right states in the equation, the reaction will not be possible.
Well, so the information that the constant gives. To see if the reacts and the products are favored or neither. If the formula gives you the K be less than 1, then the products are favored, and that means that mostly are reactants. If the K is equal 1, either are favored. It means that it's the same amount. And if the K gives you more than 1, the reactions are favored, and it's mostly products. state Le Chatelier principle. Le Chatelier principle can be used to predict the effect that something like changing concentration. So, the Le Chatelier principle will give you the changing position of the equilibrium. So, because this will be changing and shifting, so it remains on equilibrium. Well, the factors that influence the equilibrium of a reaction and the kinetics. We have some in common, like concentration, temperature, pressure, and catalyst. These ones are in common, so this means that it's going to be a change in either of these, or well, both of these. And then in the equilibrium of a reaction, we have the volume, and with the kinetics, equilibrium kinetics, we have a nature of reactants and the physical state. Then we have exercise of the equilibrium constant. Well, here I made an exercise for the equilibrium constant of a company that reports the equilibrium concentration are 0.2 m ammonia and 0.1 m nitrogen and 1.9 m hydrogen. So here I'm showing the first one, then I'm showing the formula of the for what we have already saw, that is the constant. And here we have the replacement of each one and how these are going to be, and the final result that is 0.5.
To calculate the equilibrium concentration of each element, we made this chart that it has initial concentration, the change in the concentration, and the equilibrium concentration of each element. Now, the factors that can be manipulated in this reaction. First, the catalyst. We already know that by adding a catalyst to a reaction, we do not shift the equilibrium to any side. We do not favor nor reactants nor products. However, it will speed up the process, which make this process a lot more productive. Now, the pressure. By increasing pressure, we can produce bigger quantities of ammonia. We can also change temperature. That the purpose of this is to change the equilibrium to the right. So if we decrease the temperature, this is what's gonna happen. And in consequence, we're gonna have a bigger amount of ammonia produced.